series as an opportunity for us to raise knowledge and awareness of various issues around sustainability for colleagues within our team, for residents living on Lanc West, also colleagues across the council and in other organisations that we work closely with. So today we have got a really interesting session around heat networks. So that's one of the really major bits of work happening on Lanc West at the moment, is the development of the Nottingdale heat network, which the plan is to provide an upgraded heating system that will provide low carbon heat to Lanc West and hopefully beyond. We are very lucky to have a really good team working on this, which includes Michael King, who has kindly agreed to present for us today. So Michael is our strategic stakeholder engagement manager. I think that's the right title. But he's also got loads of years of expertise and experience of heat networks behind him. So is really the ideal person to be giving us all a really good summary of what heat networks are, how they work, and how it relates to the work that we're doing. So in a second, I will pass over to Michael, who's going to be doing a presentation. At the end, we're going to have loads of time for questions, hopefully. So if you have any questions throughout them, feel free to put them in the chat and I can read them out at the end. Or if you wait till the end and put your hand up, I'll ask you to come off mute and switch on your camera if you want. We can just have a bit of time for discussion. Just in terms of like housekeeping, if we could stay on mute when you're not talking, that'd be really helpful. So just there's no background noise, and just let everyone know that I'm recording this session so we can put it on YouTube for anyone that couldn't make it. But yeah, I think that's all covered from me. So I will stop talking now and I will pass over to Michael.
Thanks, Hannah. And if I could ask you to flip over slides when needs be. Yes, I'm the Strategic Stakeholder Engagement Manager on the Nottingdale Heat Network team for Lanc West, and I share that with Jeff Laidler, who's the project manager. Janet Hall is doing stakeholder engagement with the residents, Shabir Jafari and Alekia. I'm afraid Alekia, I haven't learned how to pronounce your surname, but so it's not just me. There's a team of us working on this. But as Hannah says, that you know, I've been in this space for about 30 years, but it's probably too long. And for my sins, I'm on the board of 4 different local heat network companies, apart from working with RBKC. So next slide. I just wanted to start off with this one to point out that any energy system really comprises of 3 functions. Upstream is that you have generation, so you think of an electricity network. There's the power station at the top. It then goes through the wires, the distribution system, which actually brings the electricity down to the area where it is needed. And then there is a local distribution system, which brings it through to retail, which is all the people trying to sell you stuff on television through the meter, and that brings it to the customer. Slightly differently with gas, because with gas is that the fuel is produced upstream, distributed through the pipes, and then it is converted into heat at the within the building in a boiler before it reaches the customer as heat. Now, a heat network is pretty much the same thing. There is generation, distribution and retail, but unlike with the gas system, the traditional gas system, the generation of heat is not within the building, but outside the building, but it still contains those 3 functions. So next slide, please, Hannah. So this is really to try and explain it. Is that on one side is that you have the energy centre on the left, and then you actually have a primary network which is running around the streets, which carries the heat from there to the building to be served. Within the building, the risers and laterals, as we refer to them as, are the secondary system and go through what we know as a hydraulic interface unit into the tertiary system, which is what for most people would call a central heating system, which is the pipes and rads within the home. So next slide. So this is a describing them. On the top left-hand side, we have the interior of a plant room, and you can see that there's 2 boilers. Generally, there would be 3 boilers in line, and the first one would be to serve summer base load. So that is going to be running for most of the year, and that will be providing hot water for people in their taps, as well as any kind of heat that's needed, space heating needed during the summer. As the winter kicks in, is that the second boiler switches on, and then at the peak is that the third one switches on to meet peak load. Now, what we do is that in this particular scenario, you see the one at the far end is a green box, and that is a CHP unit. And that is generally used to serve base load so that it is running as much as possibly can, generally about 18 hours a day. And a CHP unit is in essence a big truck engine that turns a generator. So it runs on gas, it turns a generator which produces the electricity, and the heat is recovered from the engine block. In any reciprocating engine, you have cavities going around the engine block to stop it overheating, to extract the heat from it, because otherwise there's a danger that the piston will fuse in the cylinder and the whole thing will seize up. So that water circulates, going to keep the engine cool, and in a CHP engine, that heat is recovered from the engine and is put into the heat network. And there in the middle, you can see the distribution system, and there's 2 pipes, one carrying hot water generated in the plant room away from it to the buildings where it is extracted through the hydraulic interface unit. The second pipe brings the water back again at a kind of cooler temperature for reheating in the plant room. Now, if you actually look at the end of the pipes there, there's a red plastic thing, and that's just there to kind of keep the interior of the pipe dry whilst it's being installed. It will be welded to the next section of pipe and then filled with water. Now, around that kind of, you can see at where the red plastic is, it's at the end of a steel pipe. So that's what carries the water. And around that is a yellow honeycombed insulation material. So these things are very highly insulated. And around that, a black plastic jacket to protect the pipe when it's in the trench. And all of those are created in the factory. So it is a bonded unit. Very important, because as the pipe heats and cools with temperatures, is that the different layers expand. And if they're actually like put in afterwards, is that they would create friction between them, which could lead to failure. So having as a bonded unit prevents that from happening. And these are very, very effective. And I shall talk a little bit more about them a bit later. But on the right is that we see a lady with the front of a hydraulic interface unit remove the front panel. So you can see it's about the size of a microwave oven. And you have 2 pipes coming in from the bottom, which are coming from the secondary network running around the building. And that then has 2 pipes dropping out of it, which go to the radiators, and another 2 pipes for the taps providing hot water. And in that kind of hydraulic interface unit, it has a plate heat exchanger which transfers the heat from one to the other, which is the yellowy goldy thing you can see on the right, and a pump which then pushes the water around and an expansion vessel, which is that round thing that you can see just above her hand. That's because when you kind of open up the tap, your hot water tap, is that it suddenly has an incredible drop in pressure in the system, because you are in essence releasing that pressure through the tap. And so it has that expansion vessel there to cope with that, that pressure change. So on to the next slide, please, Hannah. So this is a slide from Bayes, and it explains what a heat network is. On the right, you can see all the different types of buildings that can be connected. Public buildings, off-gas gas grid buildings, so these ones don't have gas connections but could be connected to the heat network. Flats, hospitals, industry, universities, education, retail parks, swimming pools, and over on that side is that we can see greenhouses, and it's something that Hannah and I are talking to somebody about. But more importantly, in the plant room, there's which is the big circle on the left-hand side. The first circle within that, in the lower right-hand corner, is if you had just a straight boiler. Now that could run on gas, oil, or biomass, electricity, solar thermal, or indeed chillers if it's providing kind of cool water instead of hot water. All of that is fairly straightforward. But on the bottom left-hand side is that we have a series of different things that this could run on. And these are different sources of energy. So this of thermal energy. So it could be geothermal wells, it could be biomass, it could be solar, it could be a whole range of different things, including recovered heat from other buildings, from industry, from energy from waste plants, and these sorts of things. Now then, in the top of it is combined heat and power. Now combined heat and power, although I've shown you this thing in a box, and that is a typical combined heat and power unit, is that combined heat and power is a process, because a lot of people confuse combined heat and power just being about gas fired. If you actually take the heat off a power station, instead of actually throwing it up the cooling towers, as we do mainly in this country, then that would convert that power station to being CHP, to being a combined heat and power. So, you know, these engines could run on gas, they could run on oil, they could run on hydrogen, which is something to think about for the future. But it will be producing electricity, and that could be sold to buildings in the neighbourhood through a private wire arrangement, which is the arrow going up on the right hand side, or it could be sold to the externally and onto the grid for use in buildings further away. By combining that with a thermal store, which is the red circle just to the top of right hand of the larger circle. A thermal store is a big hot water tank, and what you can do is that when the grid has got too much electricity on it, is that you can absorb some of that by putting it into an electric boiler and converting it into thermal energy and storing it in the thermal tank. Then, when there's not enough electricity on the grid, you can switch on your CHP engine and export it. Now, having that kind of balancing is what we call flexibility services, grid balancing, and that is a product that you can sell. The company that operates the grid, Elexon, will pay you for doing that. Now then, Hannah, if we could go on to the next slide. So one point I want to make about heat networks is it's a way of actually like bringing on renewable energy. I mentioned all of these different sources, geothermal, heat from sewers, which is something that we're considering doing at Nottingdale. And all of these technologies are ones that are too large for individual buildings. So having a heat networks enables you to accelerate the penetration of renewable energy into the heat sector. So next slide, please, Hannah. So what are the key requirements for having a heat network? Well, the first one is heat density. Those pipes cost a lot of money, so the closer the buildings are together, the less pipe that you need, and so consequently it is more viable in towns and cities. It's not exclusively towns and cities, it can be in rural villages, but the buildings need to be tightly packed in order for it to work. The other feature about a heat density is the age of building, because over the past 150 years, buildings have got progressively more energy efficient. And so consequently, very new buildings don't actually require very much space heating. They still require hot water, but not much space heating, whereas older buildings, and the majority of Kensington and Chelsea is made up of older buildings, are quite leaky in terms of their heat energy efficiency, and therefore that is a contributing factor. The second point is load diversity. There's on the right, you see a whole load of load profiles. These are how people use heat energy during the course of the day. At the bottom is a typical load profile for a residential user. It has a big peak in the morning, it dips down, comes back again at lunchtime, and then when people come home from work at about 5 o'clock, it has the evening peak. Above that is that we have a leisure one, so not much happening during the course of the morning, slowly picks up in the afternoon with a slight bump at lunchtime when people go out to restaurants for their lunch, and then a big one in the evening when people go out to bars and clubs and theatres and restaurants, that sort of thing. Above that is an office one, which has a big peak in the morning and then a dip down when people go out for lunch at lunchtime, and then steady in the afternoon, drops off in the evening. Above that is retail, which I think is self-explanatory. Now, the point is that if you've got a gas boiler in your house, is that you most probably don't use it very much. It may seem like that, but you don't use it overnight. You don't use it mainly during the summer. You don't use it when you go away on a holiday, all of these sorts of things like that. And so, in fact, you actually use it for only a minority of the time, and that is not a good use of capital. It also means that you tend to use it in very much a stop-go sort of way. If you aggregate all those different user types and therefore those loads, what you can get is a much smoother curve over the course of the day, which actually aids the efficiency of operation of the central plant. So it's the difference between a stop-start driving within the city and cruising at 50 miles an hour down a motorway. It's much, much smoother and therefore more efficient. The last feature is anchor loads, and these are the ones that really form the cornerstones of doing a heat network. So at Nottingdale, as we've got Leisure Centre, the Academy, and Baseline Studios, and those are good anchor loads because they're continual, steady users of heat, and you can then kind of build the network around them. Typically, these ones are in the public sector. So next slide, please, Hannah. So just flashing through some the history of heat networks is that people often describe it as innovative As you can see there, it's been around since Pompeii, when people were using geothermal energy to heat the town. However, is that most people regard this character called Birdsall Holly, who was a contemporary of Thomas Edison, who established the first commercially viable network in Lockport, New York. Now, over the course of the years, is that generally speaking, through first, second, third, fourth, and fifth generation, is that the temperature of these systems have dropped. Originally, steam contained in concrete ducts, and the biggest one in the world is on Manhattan Island. So when you see a Batman movie with all the steam coming up through the pavement, that's in fact a leaking heat network. That is not a atmospheric effect. They also only have like single pipes because they blast this steam through. Within those iconic buildings in New York, is that they take the heat, but then the water is distilled out for drinking water and for use in the toilets, things like that. They don't have a return. Second generation was Eastern European. Both of these networks are generations based on coal. But there it was steel pipes, and they did have a return, but they were very, very leaky and not very popular. Third generation is what we call Scandinavian district heating, and that sort of introduced the idea of these pre-insulated pipes, and they have actually exported that technology worldwide. When we had the Arab oil price shock in the mid-1970s, is that Scandinavian... Sorry, somebody talking to me? In Scandinavia, is that they didn't have much oil or gas available to them, so they invested in energy efficiency. In this country, we bought the gas ashore from the North Sea that was being flared off, so we had a different reaction to it. We move on to 2000 and onwards, where the driver has been the climate, and here we're getting a multiplicity of energy sources, including waste heat, use of thermal stores, and temperatures have dropped down to below 70 degrees C from the 120 where it started. That is really what we're doing with Nottingdale Heat Network. Fifth generation is where you have an ambient temperature network, which is the same temperature as the ground, so you don't need all that insulation. And you can actually run cooling and chilling off it using a heat pump in every building, which can be run backwards and forwards depending on whether you need heating or chilling. However, that is commercially challenging because of the differential price between gas and electricity. Gas, up to 19 pence per kilowatt hour. Gas is only about 2 to 4 pence per kilowatt hour. So very difficult to do, but it has been done in Healing using mine water heat, and in South Bank University on the other side of the river. Okay, next slide. In the UK, it was first proposed back in 1622 by a Dutch engineer called Cornelius Drebbel. This is after Sir Hugh Middleton brought clean drinking water in from Hertfordshire through the new canal to the new river, a depot at just behind Sadler Wells in Clerkenwell, and that provided fresh drinking water to every house and building in the city. And Cornelius Drebbel's idea, well, why couldn't it be hot water, which you could then use to heat your houses? So nothing happened, but in 1901, the first system was built on the South Manchester Loop, and Bloom Street Power Station is still there, no longer a power station. It's inside the gay village within Manchester city centre. And that kind of system continued until the 1980s, when it was decommissioned because of that by then all this North Sea gas had come ashore, and it was so much cheaper that people peeled off until only one customer was left on, and they couldn't afford because all the costs were then on one customer, and so it was decommissioned. Funnily now, they're actually reinventing the whole thing. Two steam networks, these are the old Manhattan-style steam networks, were in Dundee, but the most famous recent one was Churchill Gardens in Pimlico, and the driver there was air quality. The most common form of heating in those days was open great coal fires in people's homes. And they realised that by building Battersea Power Station, they were creating much more of a burden on the air quality. And so in a way, this was a kind of an air quality offset by putting the network in Pimlico and then serving it under the river from Battersea Power Station. And it is still there. The tunnel under the river is still there. And it's now been extended up towards the back end of Victoria Station. And they've got a great big thermal store there dating from the 1950s, which has actually got a preservation order on, and you can go and have a look at it. Now, most of the systems that we refer to as legacy systems were put in the council house building boom between 1950 and 1970s. This includes the one that serves the two heat networks serving the Lanxwest estate that are now at the end of their life and need replacing. Most systems were in London, where the innovative GLC was adopting new practices from abroad, or in the coal belts of the north of England and Scotland, which was a way of the coal industry selling people coal without the means for them to actually kind of get dirty, scraping out the grate and things like that. By having a central plant room, they could just have clean heat in their homes. Now, after the 1970s, as a result of the Arab oil price shock, is that the UK brought North Sea gas ashore and that was previously being flared off. And because it was so cheap, many of these systems were decommissioned and replaced by individual boilers. However, there are a lot of legacy systems out there, and some of them are very, very popular with the people who are served by them. There were some new networks in places like Sheffield and Nottingham, where there were energy incinerators, so they're recovering the heat in CHP mode, and in Southampton, where the Department of Energy drilled a big geothermal well trying to find heat at 120 degrees C, which was hot enough to generate electricity. They found out it was only 90 degrees C and were going to cap it, but the local council, Southampton City Council, bought the well for a peppercorn and used it to heat the civic centre, which was quite close by, and that was the genesis of a whole network that now serves Southampton City Centre. Onwards, from 2000 onwards, there's growing awareness of the link between energy, carbon and climate change. 2002, Aberdeen Heat and Power founded as a result of the Home Energy Conservation Act, which was about fuel poverty and climate change. Birmingham District Energy Centre and replicated in Leicester. The driver there was financial saving. Big change was the GLA London plan in 2004, where heat networks, they had a heat hierarchy, and heat networks were at the top of that. Then in 2008, the Climate Change Act introduced this target to reduce carbon by 80% by 2050, and that was upgraded to 100% net zero by 2019. And that also created the Climate Change Committee as its statutory advisor. The Bunhill, famous one that's now extracting heat from the tube, was in 2011, and in 2013 was the first policy doc from the UK government, the future of heating, and that kind of identified heat networks as a principal plank in its decarbonisation, and established the heat networks delivery unit, which we're using at Nottingdale to advise us and support us. They were kind of created under that act. They also, 2015, created an investment program, the Heat Networks Investment Project, 320 mil, and we're going to be applying for that hopefully next week to get some money for the Nottingdale heat work. And lastly, Energetic, established by the London Borough of Enfield by our very own Jeff Laidler. So you know, we're pulling on expertise, and I serve on the board there. So next slide. Just to show you some pics of around the country. There's happening all over the place. That big white thing in the centre there is the new Tower of Light by the Bridgewater Hall in Manchester, serving the new kind of heat network, serving the south of the city. Clockwise, up the top there, centre is King's Cross. The whole development behind that is on a heat network. Over to the right is the approach road to the Blackwall Tunnel, and that is the plant room serving the whole of the Greenwich Peninsula. Below that is Aberdeen. Below that is Birmingham City Centre. To the left of that is the thermal store for the Bunhill network, which further to the left up the street there is extracting heat from the Northern Line. Above that is the energy from waste plant in Sheffield, with a whole complete network in the city centre there. The red and white thing is the Southampton station, and the car park behind it, which used to be Toys R Us, is that the geothermal well is behind a small like chain link fence opposite the station. You can go and have a look at it. And on the left there is Gateshead. The whole of like the south side of the Tyne, opposite Newcastle City Centre, is now on a developing heat network. So next slide. Just a few examples from other countries. The top left-hand side is the Spittelau energy from waste plant, and the external treatment is by the local artist Hunderwasser. And that is now a tourist destination. People go on bus tours there to see this fantastic building. On the right is the famous ski slope in Copenhagen. It's often referred to as being a power plant. It's not. It's a combined heat and power plant. It's also supplying Copenhagen, and 99% of all of Copenhagen is on a heat network. Down on the bottom left-hand corner, that is a geothermal power station providing heat and power from all the volcanic activity in Iceland to Reykjavik, which is 99% on a heat network. On the bottom right-hand corner is Vancouver, where they're extracting heat out of the sewer there. And those like purple flues on the top is that they turn red when it's actually kind of working at its peak, and phase out to blue when it's not using much heat. So next slide, please. So what this is, we are actually trying to do this at Nottingdale. As I mentioned, there's two existing heat networks at the end of their time. So we want to replace those, integrate them, bring on some of the surrounding buildings, including the Academy, Leisure Centre, Baseline Studios, North Kensington Resource Centre, and the Community Centre. And this is going to be co-designed with the residents. A driver is to actually provide them with low-cost energy. So we're developing a price promise for them. We'll have a new renewable energy centre. Initially, that's going to be run on air source heat pumps, but we hope in the future we'll be able to extract it from the sewer or even an aquifer below there. And then we're going to expand it to a further 500 and 800 additional homes in the Nottingdale ward. And once we've established the model, is that we hope that we can then apply it to elsewhere in the borough. So next slide, please. So now we're flipping back what's looking at in the past to what's looking forward. As I mentioned, as the government's committed to net zero carbon by 2050, and that is across the entire economy, including heat, which also is the most difficult to decarbonise. With electricity, you can flip out the power stations for wind farms and nuclear power stations like that without troubling the people in their homes. Within heat, you actually have to start kind of getting involved in people's homes, and that is very, very difficult. But 85% of the gas is produced from fossil heat in this country, and we need to get off of that. And nothing has very much been changing since 1990, as you can see on the right hand side, is that between those two dates is that the carbon emissions of heat remain at 31%. So next slide. So this is a timeline of what's happening, is that from 2025, no new buildings that are being newly built can have a a gas network connection. From 2035, existing boilers cannot be replaced in public and commercial buildings. And then from 2033, in fact, Climate Change Committee have slipped that to 2035, that will be phased out in residential buildings. So the challenge is, what are we going to do instead? So next slide. So Bayes, in their clean growth strategy, outlined three possibilities. One is electrification, hydrogen, and the third one is carbon extraction. We don't need to trouble much with carbon extraction because that is mainly about reforestation, peat bog restoration, and carbon capture and storage. So the Climate Change Committee looked at those and essentially boiled it down to three, which are hydrogen, electrification, and a hybrid. And I'll run through these in the next slide. So over to the next slide, please, Hannah. One is electrification. So there's heat networks, there's power networks all over the country. So it is quite possible to flip them over. It's likely to be heat pumps, because for 1 unit of heat that you can put into, 1 unit of electricity put into a heat pump, you extract 2 to 3 units of 2 to 4 units of heat out of it. It's rather like your fridge, in that it's got something there that extracts the heat out of the container with all your eggs and butter and milk in it and dumps it into the room. A heat pump does exactly the same, except it captures the heat from outside, from water, sewers, or the air, and actually pulls it inside the building. It's very efficient. And that's why it's important, because if we just go for resistive heating, which is only 100% efficient, it means that if we're going to electrify all our transport, there's going to be a massive increase in upstream distribution and generation. So the difficulty, as I mentioned before, is it uses high cost electricity, and it doesn't provide power revenues as it does with CHP. But it is market ready and available out there, but at a price. It's quite big. It costs £16,000 a unit, and it has difficulty being turning it up and down, so it means it has difficulty meeting surges. Hydrogen, on the other hand, on the right hand side, is like a gas boiler with the existing arrangement, except it runs on hydrogen. But that is only 80% efficient in converting the gas into heat, compared with the up to 400% of a heat pump. The trouble is that a lot of work needs to be done in changing things over, because the flame is different, the molecule is different, and the upstream the hydrogen no plant currently exists for the creation of hydrogen. Blue hydrogen, which is stripping out the hydrogen from methane, and the carbon remains and is dumped into carbon capture and storage. Green hydrogen is using electrolysis to split the water atom into hydrogen and oxygen, which both of these processes require an awful lot of electricity. So the hydrogen generation distribution supply is not currently available and is unlikely, according to the Climate Change Committee, to be widely available before 2035. So next slide. And this just sort of shows the sort of variability between heat demand and electricity demand over a year. Heat demand, electricity demand is the blue line across the bottom there. It's fairly constant, and that is what the current grid and generation fleet and design are designed to meet. Heat drops down in the middle during the summer, but is up during the winter on either sides, but it has these incredible peaks. Now, the implication of electrifying without doing anything else is that you would actually have to expand the grid and generation fleet to meet those peaks, and that is could cost a lot of money. So next slide. By contrast, is that if you have a hybrid approach, is that say have electric heat serving that kind of base winter load, and then hydrogen for the peaks winter over summer, but also, you know, those kind of surges in demand, that could do it. And the industry is currently developing in-house units that are hybrid heat pump hydrogen boilers, but they are very bulky. And also, of course, you can only tackle on gas grid properties with those. So, but it can produce net zero carbon at a reasonable cost, which I shall come on to in a moment. However, I make the point that heat networks can actually do this very easily, and it can actually blend not only heat pumps and hydrogen, but all sorts of other technologies, as I outlined in the slide at the beginning. So you can put in additional backup capacity, backup generation, which is very difficult in a local within a house because of the space limitations. And you can also blend in other sources such as waste heat from other buildings and energy from waste plants. But also, once it's installed in a person's house, you can flip out the generation plant for something else without messing with the people in their homes. So next slide, please. So costs, as you can see there, is that this was done by Imperial College in 2018, before the government adopted the 100% net zero carbon target, which is the one on the right-hand side. And you can see hydrogen is 121 billion, electrification 92 billion, and a hybrid 88 billion. Now, all of these costs are likely to flow down to the end consumer. So if we care about fuel poverty, is that it drives us towards the hybrid solution. Next slide, Hannah. So my last slide is, what pathway, these different technologies, where are they going to be done? Climate Change Committee suggests that in the industrial areas such as Teesside and Grangemouth in Scotland, the South Cheshire Basin, is that will be hydrogen, because hydrogen is required for those industries. So it justifies the expense of investing in carbon capture and storage. But if you've done that, you might as well connect up the buildings in the vicinity. That is not the case for places like London, which are kind of very, very dense, so they're very suitable for heat networks, and so hydrogen is not likely to be the selected opportunity here. In the new London plan adopted at the beginning of this year, they have said that they are going to introduce heat network priority areas, and they've got a team of consultants working on that. And as you can see from that map, Kensington Chelsea is wholly within one. And then in the energy white paper is that the government have said that they are going to introduce heat network zones by 2025. So all of this is happening. So that's it, Hannah. I think that's my last slide. So yeah, open for discussion and any questions that anyone would like to put.
Thank you. That was really just got a bit of it. Not sure. But yeah, does anyone have any questions? I know that one, so jumping quickly. You know roughly proportion of the UK is currently on a heat network. What kind of proportion of buildings it would make most sense to in terms of efficiency to be on them in future?
Okay, so because of the echo, I'm not sure I got the question right, but I'll try to answer what I think it is. Previously, the government collected figures according to fuel type. So they had ones for electricity, gas, this, that, and the next thing. They didn't do it by service. So the figure that they did have was approximately 2% of the total heat of all the building stock was on a heat network in 2000, and that figure has been used ever since then. In fact, it's most probably an awful lot higher because of the GLA's London Plan new obligation, and so all of these new tower blocks that are going up are on heat networks, so it's most probably higher. The clean growth strategy suggested that approximately 20% of all buildings will be on heat networks by 2050, and that is whatever pathway that they decide to go down. I think the second part of your question is that what is number of flats or houses or buildings do you need to make a heat network viable? And the answer to that is it's as long as a piece of string. And that might seem like I'm avoiding the question, but theoretically is that if you have two houses sharing a single boiler, that is a heat network by definition. So a lot of it comes down to how close they are, is there an anchor load present? Is there a source of renewable heat or waste heat available locally? What are the mix of different load profiles? All of that sort of stuff will depend on how many properties you need to make it viable. So theoretically, it could be two, or it could be up to whole towns and cities, as they are in Copenhagen and Reykjavik and places like that.
Great, thank you. I can see we've got a couple of hands up. I'm not sure what order you came in, but Gonzalo, do you want to go first?
Hey, Michael. This is more than a question, it's a comment. I am an energy manager, and one of the issues that I have with a lot of the work that we are doing is that the government is not addressing how much our buildings leak, especially for buildings that are protected. We have a lot of leakage, and a lot of our properties are not airtight, and that is a quite big problem that is not being addressed in a more urgent manner.
Thank you very much for the question, Gonzalo, and a very pertinent one at the moment, because the government announced that they were introducing a Green Heat Networks Fund, and this is to switch over existing fossil plant over on heat networks to green heat sources. And we all attended a presentation last week done by Bays. And at the same time, they popped up this presentation about a heat network efficiency scheme that nobody knew anything about. And they kind of ran through it. And so they are proposing a funding program to help address the sort of issue that you're talking about. So, if there's something that is inefficient at the moment, this is designed to help that. it didn't actually say how much money was involved. And I did some work with Southwark several years ago, many years ago, and I think at the time, because Southwark's got more buildings on heat networks than any other local authority in the country, and at the time that they needed to spend, I think, 100 mil to bring it up to scratch, and yet they only had a 10 mil per annum budget. And so, if you spread it across every local authority in the country, there's a huge amount of money to be spent on bringing those old legacy systems up to date.
Thank you for the comment. And it's not just our old buildings, but a lot of the buildings are conservation buildings. Yeah. From my perspective, they leak so much heat, and no one seems to be doing a lot about it. Then.
We are also on the Heat Networks team endeavouring to raise money from the GLA to undertake a cross-borough energy master plan, and the objective really is to identify other opportunities in the borough where we can repeat what we're doing in Nottingdale, and that might encompass some of the private buildings that are on heat networks that you described there that could possibly benefit from this sort of investment. I think the other person's put down their hand, Hannah. I've blinded them with science.
John, did you still? John,
yeah, I did put my hand down.
Yeah.
Sorry. It's more of a comment, really. I'm in the planning department, and we're just finishing off doing planning guidance for Kensal, which will go up Kensal Opportunity Area, which will be adopted hopefully by our leadership team in early July. But I'm conscious that we haven't really progressed a heat network for Kensal, which is obviously an opportunity area. And although Earl's Court is behind that, it's gone back to the drawing board. So similar comment for Earl's Court to a degree as well, although I think previously they had talked about a heat network. I was really just sort of a comment, and I noticed that you said, obviously in the London plan, you're quite right that heat network priority areas would be prioritised by the GLA, and I think Kensington and Chelsea, as you said, falls within that. But it seems to me that for our largest sites, we seem to still be behind the curve on this. And just looking at the problems with Kensal, which has got 5 different landowners, and it's split between 2 different sites with a railway running between them, it seems to be incredibly difficult with all the other factors that we've got to try and wrestle with on that site to actually see whether we can actually do it. They're all coming in at different times with planning applications, and in fact, I think the first applications will come in even this year. Well, I mean, probably even as early as sort of late September, early October, and yet I'm sort of conscious that we haven't necessarily sorted that side out. So it's really more of a comment that we always put it in the plan, we always support them, we put it in policy, we think it's a great idea, and we support the notion of it. But the practicalities of actually bringing these forward always seem to be the thing that somehow is the game changer and doesn't happen. So I just wondered if we were further on in getting somewhere with that, because at the moment I still get the feeling we're not. We've talked about heat networks for a number of years, 10 years at least it's been in our local plan, but if I was honest, nothing's really moved on it in some ways.
Okay, well, thank you for your comment, John. And one of the great risks, if you like, in doing heat networks is what is referred to as a demand risk or connection risk, and that is that if you're an investor, and it doesn't matter if it's a public investor or a private investor, why would you invest hundreds, millions of pounds putting pipes in the ground if you didn't have any guarantee that people were going to connect to that network and consequently provide you with a revenue in order to be able to pay the capital expenditure that you repay the capital expenditure you've invested. So actually, making sure that those connections are there is very important. And one way of doing that is through planning. The other way, and where it's like typically happened, is because the people that are promoting it can control the buildings and oblige them to connect. So that would be a local authority which actually has a public housing estate, and it can say that all of these buildings are going to connect. Similarly, is that you have a kind of a campus site, such as a university or like a big property development. I mean, there are ones up on Merseyside. Peel Land Holdings have got a company called Mersey Heat, and because they are the landowner, they can oblige all the buildings on it to connect. Now, in respect of Kensal Rise, is that there's two kind of opportunities there. One is this a potential for northward expansion from Nottingdale in the fullness of time? And secondly, is that it is adjacent to the Old Oak Common site, where there's a huge amount of development and all on a heat network. So it could approach from both sides. But if those buildings go ahead without the secondary networks inside the building, it won't be possible to connect them to a primary network. So, I would encourage you and your colleagues in planning to make sure that they have those secondary networks within the buildings, so that when the primary network comes along, either from the south from Nottingdale or from the north from Old Oak, that they can connect. Also to say that I have actually been commenting on the greening SPD for Preety. So hopefully, as that we sort of strengthen that in terms of what you're requiring of developers.
Okay, thank you. That's really useful. Thanks, Michael.
Thank you, Jonathan.
We've just got one more question in the chat from Selena, which says, I'm assuming this is in relation to the Nottingdale Heat Network, asking when it's proposed that the works will start happening for that, and is there a deadline for the works to be complete?
Okay, I would like to have the thing in front of me, which I don't, and Jeff's on the call, and he most probably has got it on the top of his head. So here he comes. So Jeff, if you want to answer that particular question, I can have a stab at it, but I think you'd be best placed to answer.
Sure, no problems. So for the works within inside the blocks, we'll be looking to start as fast as the refurbishment programme happens. So we're aiming to put residents first and minimise disruption. So from the beginning of probably 2022 through to 2026, we'll link in with the refurbishment, and we'll put in the new pipes within the blocks, within homes, and give residents the control of their heating, which they've said that's sort of top of the list of wishes for the new heat network. And in parallel to that, we'll then be looking at installing the new network outside the blocks and the new energy centre. So the programme at the moment is to start in 2023 and finish in spring 24. So that's really when any home that's then been refurbished will then connect to the new renewable heat network.
Thanks, Jeff. We've also got a comment in the chat, which I think is a fair one, asking about kind of the priorities around the heat network and ensuring that like quality and the heat network actually being done right rather than as cheaply as possible is going to be like the #1 priority. So I think you two could probably say a bit more about that.
Okay, well, that was a problem when the GLA first introduced this priority in the first London plan, because a lot of developers were putting up these blocks and trying to do it as cheaply as possible. And they were doing what we call value engineering, where they were removing anything they thought was not necessary. And sometimes this compromised the original design integrity. And so consequently, the GLA initially produced a set of standards that were attached to their planning requirements. Subsequently, the Chartered Institute of Building Services Engineers have actually introduced a code of good practice, and that has now been through 2 reiterations where they're upgrading the requirements in it. And most planning requirements, when people put in an application and it is approved, is that it is attached as a condition that they must meet the conditions laid out in the GLA District Heating Manual and the CIBSE Code of Practice. And so that is an attempt to address this kind of issue of poor design and people trying to cut corners and get away with doing something as cheaply as possible. Because at the end of the day, if you do that, it doesn't deliver for the end residents. They end up paying sky-high bills, they're overheating in the blocks, and we're not saving carbon. So, we've got to sort of drive this bad practice out.
Thank you, Michael. Does anybody have any last questions? I know we're a couple of minutes over now, so if not, we'll bring it to a close. I'll just give one final chance. But yeah, if nobody has anything else, then we'll close that here. Just again, thanks so much, Michael. I think the presentation was really interesting. Hopefully everyone feels like they've learned a lot, because I know that I definitely have. Thanks everyone else for joining the call. I'll put a link in the chat to our page on the We Are W11 app, which has recordings of all past sessions, and this one will be up there too. So if anyone couldn't join today, then yeah, they'll be able to see it there. Again, thanks everybody. And
in closing, Hannah, could I just say that we are there trying to deliver the Nottingdale Heat Network, but the Heat Network's team is there, and we're available if anyone wants to use us as a resource in terms of asking questions, advice, or anything like that. So please do give us a shout.
Great, thanks, Michael. Thanks everybody.
Thank you. Oh, thank you so much, Hannah and Michael. Thank you very much.